Hello guys and gals, welcome back to my channel again. I'm Cemil Turan and today I'm gonna discuss steroidal hormones again. I hope in this video you will understand the androgen molecules and progest, progestins and progestogens in general, and also progesterone molecules, including the progesterone molecules too. So for example, behind if you look at if you look behind a supplement that contains prohormones or over-the-counter aromatase inhibitor, you can easily see that they contain they the the ingredients they list are generally not even closely even readable for an average Joe. So most of the people, it might be including you, don't understand that even at all, very close to zero. So what I want to address is how you can imagine or draw the molecules according the label. That's what I'm trying to do. So if you take a look at the old cholesterol hormone, it has 27 carbons, and if and with almost every step of the steroidogenesis, they lose the carbon numbers. For example, cholesterol has 27 carbons, but androgens has 19 carbons, and estrogens has 18 carbons, and gonads has 17 carbons. Also, keep in mind that there are many birth control oral contraceptives for female use, but most of them are 19-nor-testosterone derivatives. If you take a look at my previous videos, you can see that nandrolone family androgens, also called 19-nor-testosterone, they lack the ninth carbon at the 19th position, so they have one less carbon. So estrogen and gonane family actually belongs to 19-nor-testosterone family too. They both lack the carbon at the 19th position, as you can see. So there are multiple groups. There are some groups that we need to know if we want to imagine or draw the molecules behind those labels. And one of them is ketone group. It is the oxygen atom double bound to rest of the molecule. If you take a look at the third position at the testosterone molecule, you can see the ketone molecule there. Also, they are also described as on or ONE. Also, there are methyl and ethyl groups. Like methyl group is carbon and 3 hydrogen atoms. But ethanol group is CH2 and CH3. Also, a hydroxyl group, if you take a look at the 17th position of the testosterone molecule, you can easily see hydroxyl molecule. There also abbreviation for the hydroxyl group, HO group, is iol. Also, there are alpha and beta position. Alpha and beta position describes the proximity to functional group. Alpha is 1 carbon away and beta is 2 carbon away. Also, the alpha and beta can stand for the how close how a group is, how close it is to the surface of the molecule, the depth. So with the three, for example, we can give the 5-alpha reductase enzyme. With that, the double carbon bond between the position 4 and 5 reduces, and you get the hydrogen atom that stands behind or far away from the surface. But with the 5-beta reductase enzymes, which is also in the bone marrow, you get the reduced form of the 4th and 5th position. The 5-beta reduced form has hydrogen atom closer to the surface. So we have also double bonds, also called as ene. So let's take a look at to our first molecule. It is androsten 3,5-diene 7,17-dione. I know it looks quite complicated, but actually it is not. It's quite simple. Like let's break it down. Let's break that molecule down step by step. It is an androsten derivative, so it has 19 carbons, and naturally it has a cholesterol backbone. Remember, ABCD rings. Don't forget those. It has diene, which means that it has 2 ene groups, which means, again, 2 double bonds. And we have dione, 2 ketone groups. So, how do we draw that molecule? Is you draw the ABCD rings according to androsten's structure. You put the double bonds between the position 3, 4, and 5, 6. And you put 2 ketone groups to position 7 and 17. So, you see the ABCD rings on the right top of the screen. You can easily see the ABCD rings. And you put the double bonds between the 3, 4, and 5, 6. And you put 2 ketone groups at position 7 and 17. And also, if you put the hydrogen groups in correct places according to androsten skeleton, the end product you get is aromastane, which is an over-the-counter aromatase inhibitor that you can, if I remember correctly, you can still find it in supplement stores in the United States particularly. Let's take a look at our second molecule. It is 17-alpha ethanol, 18-methyl, 19-nortestosterone, 3-oxime or oxime, 17-beta acetate. So, obviously, it is a 19-nortestosterone. It's structurally related to nandrolone. It has acetate ester attached to its 17th position. There is a methyl group at or on the 18th position. Ethanol on 17th position and oxime on 3rd position. Okay, we know I suppose you know the nandrolone molecule, aka 19-nortestosterone. We draw that and make modifications on that molecule. After drawing the nandrolone, you literally erase the ketone group on 3rd position and you erase the hydroxyl group on 17th position. So, and then what you do is you just add acetate ester to 17th beta position and add ethanol group to 17th alpha position. And you add oxime group to 3rd position and add methyl group on top of 18th position of nandrolone molecule. So the molecule we get is no guesstimate It is actually a 19-testosterone derivative used for contraceptive purposes. It lacks the 19th position, as you can see. So it's a strong progestin and a weak androgen, and it strongly suppresses HPTA. That's what birth control oral contraceptives do. They suppress HPTA. So the last molecule I'm gonna discuss, we're gonna break it down, is Estra 4911 triene 37-dione. Obviously, it has a strained skeleton. So it has 18 carbon, and it doesn't have a 19th carbon. So there is no methyl group on the 19th position. Also, there are 3 double bonds between the positions 4, 5, 9, 10, and 11, 12. Also, there are ketone groups at positions 3 and 17. The molecule we get is very similar to trembolone, actually, if you take a look at it. It has 3 ene groups, 3 double bonds, and those 3 double bonds are at the same places as the trembolone has. So it looks very similar to trembolone. Can it be related? As a naturally occurring question you might ask yourself, that can it be structurally very similar to trembolone? Can it be like methyltrinolone? It's called trinolone. Can it be methyltrinolone? It resembles that, right? And actually, not. It is not neither of them. It's neither trembolone or nor methyltren or methyltrinolone. It is actually known as tranovar or trendione, a trembolone that has 2 ketone groups, and it works as a prohormone, and that thing has been banned since circa 2015 in the United States. Via 17-beta hydroxysteroid dehydrogenase, it becomes a trembolone. It gains the hydroxyl group at 17th position of trembolone, as you can see right now on top of the screen. And the end product you get is trembolone. So, and that's pretty much it. That's pretty much it, guys. Now you know how to imagine or draw the molecules you see on the supplement facts label behind its package, or you see on the internet. And thank you so much for watching, guys. If you like this video, you can comment, share, and subscribe to my channel. As always, till next time, have a great day.